Hey everyone. Today we have Todd Lewis. He's a senior engineer from Breakabode, and he's going to be talking about PL.NET extension for Postgres. Todd, the stage is yours.
Very good. Welcome, everybody. Feel free to interrupt me with any questions, and I'll get into it. PL.NET is an extension to PostgreSQL, adding support for .NET with the full range of PL functionalities. So that's stored procedures, functions, do blocks, and triggers. And we're pretty feature complete. The feature list is in the white paper. I'm using the white paper for this talk, but it's a pretty complete implementation. When I say .NET, that is both C# and F#. We did not add Visual Basic. If anyone would like Visual Basic support in PostgreSQL, we are perfectly happy to do that, but someone would need to pay us. We were only willing to do C# and F# for free. C# and F# are both fully supported. We have complete unit testing for both languages across all supported features. And let's see, what can I tell you about it? It's feature complete. We have native support for, as of this version of the white paper, 38 out of the 46 standard user types. Native support is something I'll explain a little later, but this is in contrast, for example, to Tickle, where almost every data type is just the default Postgres textual representation of the value. We actually have .NET objects. And we are aided here through our leveraging of NPG-SQL. And NPG, I think this is a really important part of how we did it, and something I think deserves much more attention in procedural languages in Postgres. .NET on Postgres is really blessed in having a single canonical client API, and that is NPG-SQL. NPG-SQL is really good. It follows the age-old ADO.NET standard for accessing relational databases in .NET, which is an extension of the older C++ ADO standard. And we incorporated NPG-SQL wholesale into PL.NET. And we replaced the low-level client behavior with SPI calls and with the type adapters. So at the low level, instead of behaving as a remote client to Postgres, NPG-SQL instead talks direct to Postgres from inside of the server. But at a high level, it's presenting the exact same API to developers. In principle, we should be able to get it to the point that the code compatibility is perfect, and code should be able to migrate unmodified between the client and the server. And this is really central to what we're trying to do in the entire project, is allow developers the freedom to run their code in the place where it makes the most sense. And that's why NPG-SQL is really central to what we built. I want to give a shout out to the NPG-SQL team. They do great work, and it was really central to the success of our project. And I think everybody should shower them with money and attention and parades and stuff. So when we say it natively supports these data types, that's the specific meaning. It is mapped to the native normal type representation in .NET. And again, that's part of our bigger vision of allowing code mobility. It's free software, of course. It is very well tested, and it is very fast. So in a minute, I'm going to talk about just how fast and how well tested and how awesome it is. But I'll stop there first and see if anyone has any initial questions about that introduction. You can raise your hand, or you can just unmute and shout out. Anyone at all? Yuri, if you were a hypothetical newcomer to this, what questions would you have at this stage?
That's a good question. You probably will answer it later, but I'm curious if you will be able to address questions of any overhead in supporting different data types, as in
Absolutely. We have a whole section. We have a whole section.
Yeah,
we have a whole section of the white paper about that. So
perfect. So I'll wait until then.
Sure. And so let me talk first about our testing. We have, let's see, as of this version of the white paper, which is slightly old, over 1,000 unit tests. And again, that is both C# and F#. And I'll just go to the Git repo here, brickabode/pl.net on GitHub. And we go to test. And, oh, dang it. Here's C#. These are the SQL tests. And here is F#. And I'll look at F# because I like it. You can see it's a normal PL. The SQL is perfectly normal here. The procedural language goes between the dollar signs, and this is just F# code. But we've got really extensive testing here, which is also useful if you're trying to figure out how to use pl.net. If whatever it is you're trying to do, you can probably rummage around in the test and find examples. And you can see we have it by data type, but then we also have it by feature. Triggers are here. Triggers are tricky, but we have all the normal Postgres trigger data objects are exposed. So if you're looking to use pl.net, I encourage you to look in the. We also have ported them from just raw SQL to XUnit inside of .NET, and those are here. And these are probably a little better organized. The testing support is really good, and we don't ship unless all the tests are passing. And we try to be really conscientious about making sure that any feature we add has good test coverage, because that's what I would want out of my PL if I were looking to use PL. So that's the testing. I'll brag about one other thing before we get into the architecture, which is the performance. Actually, in order to explain the performance, I have to show our performance tests, which I think are actually very relevant to this audience. Let me collapse this down here, blah, blah, blah. So this was some of the first work we did in the project. We went through all of the standard procedural languages, and we did a standard set of tests to cover all the languages. And these are just simple usages of the different features, data types, mostly arrays, composites, do's. But we implemented this for all of the languages in this list. So Java, Lua, PGSQL, Python, R, Tcl, and JavaScript. And we then use this to do a benchmark. And in our benchmarks, PL/C# and PL/F# are the fastest languages in PostgreSQL, which is something that's important to us. Here we set PL Python as the benchmark, and it's right in the middle. Now, PL PGSQL is very competitive with us. We're only a tiny bit faster in our benchmarks, and if you had skewed these benchmarks a different way, you could probably get PL PGSQL to beat us or not beat us, depending on how you tune the benchmarks. And here, PL Perl is within spitting distance. PL Python is fine. With Tcl, Lua, Java, JavaScript, and R, the performance drops off here. But we have the full heat map, and there's a lot of interesting stuff here. We are really happy about being fast. I think it's funny that where's the recursive test? Yeah, that F# just actually smokes on the recursive test, but C# does as well. This is actually what killed PGSQL. In the original version of this, F# absolutely blew everything out. So this whole map was red and F# recursion was green, which if you know anything about functional programming is hilarious. So we actually had to tune down our performance on the Fibonacci test and the factorial test in order to just have this data be useful. So that was the only fiddling we did with the benchmarks, was actually to make C# and F# slower. And I think we reduced those to only 2 or 3 recursions. But I do think it's an important thing to measure, especially when you have a functional language like F#, and .NET handles it really well. So I do think it's a fair test. But anyway, this is, I think, of special interest to this group, which is looking at collaboration across different Postgres extension authors. And PLs are, to me at least, the dominant category of extensions. Other people who are interested in different things might have different value judgments about that. But I think PLs are definitely a really interesting category of Postgres extension. And one thing we've really been interested in for a long time is more collaboration at a minimum among the PLs. And we've at different times tried to bang this test suite and future versions of this test suite into a shared test suite that we all could be using and be collaborating more as a community, both helping each other. For example, I think a lot of these R performance problems could really be improved very quickly if someone paid attention to them. So we're not going to do that, but if someone is using PLR and is frustrated by the performance, these benchmarks could really help you spot them. And I think that can be helpful. I would have loved it if someone had written all this testing for me. So that's one specific thing I'll point out about potential collaboration, and we can maybe talk about it more later. But point here at the beginning is the performance is really good, and that was important to us. And here we show the shape of the graph where we compare C# to all these other languages and just show where they outperform us, where we outperform them. And for most of them, you can see we outperform them on all of the tests. So I think that gets to your overhead point. Our overhead here is really good, at least comparatively speaking. And now I can talk about why and how. And that's actually this graph, which let me zoom in a little bit. Is this visible or should I zoom in more?
I would say just a little bit more, depending on the size of the
Yeah,
screen.
sure. Let me go in here. So here we have the call graph, and we show just a trivial example to show what the data flow is like. We have the data handler that's registered in Postgres, and that then goes to pl.NET C code. And in C, we call directly into .NET with call user function. So here we go into C#, and C# receives the datums from C, and then does a callback into C to marshal the values out. So you can see this is the type-specific call. The arguments to this function are int32s. In C#, we pass the datum back to C to get the value out. Excuse me, and we do that for both the arguments. Here it's an int32 and an int16. We debated doing this directly in C#, but with all the macros, if anyone's ever done this kind of programming, the Postgres APIs is not very straightforward. It's macro heavy and it sometimes changes over time. And the overhead of a small function call here was not that great. So we decided to prioritize just leveraging the fact that Postgres does this really well, but it does it with CPP, not with code, to have the actual marshaling from the datum to the value be done in C. But the general theme here is we do try to do as much of this in C# as we can. We do try to minimize the C code wherever possible. And where there are C calls, you have things like pl.NET get int32. It's very type specific. It's very minimal. And we try to get in and get out. Hello, goodbye. We try to do everything in C# that we can. And I'll talk about that maybe more in a minute, but just going through this. So we get the values out, and then we do the actual function call here to the user function, which here we're just adding 2 integers, and we return it. And then we do the same pattern on the way back down, where we pass the value to C and have it convert it to a datum for us. And here again, this is an int32 specific call. And then we return that datum down to C, which then returns it to Postgres. Different people on the call might have different familiarity with these APIs in Postgres and how PLs are structured. So I'll stop there for a minute and ask if anyone has any questions about how this works. Anyone? Was it clear? Did it make sense?
I just have one question here. I'm curious, what was your motivation behind making calls, those calls to get data in and out of datums for very basic types? Specifically, I can probably understand the reasoning behind using Postgres' own macros to, say, get and retrieve complicated types of some sort. But what about things like integers? What was your rationale behind making a colon
We
as opposed to just knowing how datum is organized for these types.
Yeah, we could have done a hybrid thing where we use Postgres for the complicated types and then we do the simple types directly. But what we did instead was we just picked a strategy and we executed it. And then premature optimization being the root of all evil, we said to ourselves, if it is a performance problem, we'll see it in the benchmarks and we'll deal with it then. Okay. But if you look at the actual instruction counts on an x86 for a function call that marshals an integer, it's less than a cache miss. The overhead here is really insignificant. So that's why we weren't strongly motivated to go back and selectively marshal integers or whatever. The only time it really matters is on an array. And on an array, we don't have 1,000 calls. We'll have a single call. So that was the reason why. Did that answer your question?
Yeah, that's a very good point. Although it would be, of course, interesting at some point in the future to see if there is actually a difference.
Yeah.
When somebody's really bored and trying to, replace those SQLs with just doing it directly and see if it's actually just negligible or not. I think it will be interesting to experiment, time permitting.
Yep. But also just general motivation. Our performance is so good. That's not the place where we should be applying our efforts to make the system better.
That's a very good point.
And this is a labor of love for us. And so we have limited resources for it. And so we want to make sure that our efforts are pointed at the things that's really going to help our users the most. And that's not performance. Thankfully, that's a very happy story, right? Our performance is really good. The other thing too that I would mention here is a major difference between us and the other languages. And this is counterintuitive, so I feel the need to point it out. Moving the data marshaling and whatnot out of C and into C# was a huge performance boost for us. And the reason for this is not necessarily obvious. The reason is we are able to lift the decision and the analysis of which marshaling to do. We are able to lift that out of the runtime and up to compile time. So both the function and the handler for the function are in C#, except when the function is in F#, but that's trivial in .NET. I'm going to ignore that and just consider the C# case. Both of those are code generated and compiled. It uses Roslyn for C#, and we have both F# compiler services and just the straight compiler for F#. F# is a little tricky. I'll ignore that. But by compiling them, we know at compile time exactly which types are coming in and exactly which types are going out. And because of that, our C# is dramatically faster than, for example, the C handling of the same function in PL Python, which I'm not picking on PL Python. It's just it's a standard, it's a normal example, and it's my benchmark because I really like it. The structure of the C code in PL Python does not know what the types are. It has to dynamically look at them and then go through a big switch statement and find the handler and then pass them around in some kind of generic way up to Python. Whereas we know at compile time exactly what the types are. And so we have the minimal perfect handling of each type at each stage because we do that analysis at compile time instead of runtime. And as a result, our code path at runtime is really minimal compared to the people who have done this in C, again, because we're able to lift that analysis out of runtime and into compile time. And I think more people could be doing this. I think more people probably should be doing this. And it's one of the things I think we got really right here and that really helped us. And that's the overview of how we do data marshaling. I mean, this is the major function that the PL handler does. The actual function execution is done by the runtime. .NET does that for us. It's our job to get the data in, get the data out, and have the function run well. And this is how we do it. Any questions about that? No? Okay. That's pretty much the overview. I'm just looking at my notes here. We talked about the architecture in PGSQL, why we use C sharp, how we compile. I talked about performance and I talked about testing. Any other questions about the architecture or things that people want to know?
I have a question.
Yeah.
Can you elaborate more on how you compile functions in runtime? So let's say somebody is sending command saying create function such and such
Yep.
in C sharp or F sharp. Here is the source code. How do you compile it? What are the requirements for whatever software that you need to get installed on that server? So basically, what's the pipeline for getting from this statement that you're looking at
Yep.
to something that works? Like what's happening underneath, and what are the requirements for that to be successful?
Yeah. I'm very happy to talk about that. Excuse me a minute. GitHub's code highlighting is very visible here. Let's consider this modified bit function. Okay. And you can see the SQL spec here, and then the body is in C sharp. We and I'm only going to talk about C sharp. If anyone has F sharp questions, I can answer those, but I think it would be tedious for me to give two explanations for everything. So I'm just going to give the C sharp answer. So what do? We preserve the argument naming from SQL. If your SQL argument is named A, then it's called A in your C sharp code. We code generate the class and the method for this, and then we compile it. And .NET has beautiful facilities for this, really beautiful in Roslyn, which is a framework. It's a recent innovation in .NET, last 5 years or so. But Roslyn takes the entire compiler pipeline and decomposes it into useful library pieces. So you don't only have a compiler, you have the parser that takes the string and gives you the abstract syntax tree. And the abstract syntax tree is really rich, so you can go and run code checkers on the AST. This is interesting from a security perspective. You can then compile it down to bytecode and load it, and that's what we do. So we code generate both the function itself and our wrapper for it. The wrapper is the thing that gets the data in and out of Postgres. We compile them. We get something like a function pointer. It's a abstract handler. I think it's a delegate. And then it's in our cache and we can pull it out and we can run it when a function call comes in. And what else can I tell you about that? Oh, it runs inside of, in .NET, what is called an assembly load context, which is a .NET sandbox. And that has its own DLL space. So we can control on a function by function basis which libraries get loaded in. We've not done nearly enough with this yet. I really want this to be much better, where right now every function is in its own ALC. That's not ideal. We want developers to be able to control which functions share a context and which functions are isolated. We want to give them richer facilities for importing libraries into specific contexts. And that is all doable. We have plans and we even have some limited prototypes for doing that. We just haven't gotten to it yet. This is also the mechanism we use for loading DLLs. I said that we code generate it, but we only code generate it in the case where you pass the source code to create function in SQL. We also have DLL support, and you can see that here. And this is, I believe, how PL Java does everything. Here you can create a function and you can create it as this. So there's the path, the file system path to the DLL, the class and the class name, and then the function name. And in that case, we do not code generate it. We just load the DLL into the assembly load context. And then we do code generate the wrapper, which gets the data in and out. But we fully support both modes. I think we might be the only PL to support both modes. I think PL Java only supports loading from a class. I don't think you can use the language, you put the Java code in your create function, but don't quote me on that. I could be wrong. And um, and that's how we do it. So, did I answer the question? Do you have any follow-ups?
I do have a follow-up. Can you explain what do you need to have installed on the server where you have this Postgres for all of this to be possible? So when I install the
Yeah,
extension, what else needs to be there?
all you really need is just the standard Linux net installation. It's a collection of 3 packages, but it's in the dependencies to RD package. So if you just apt install it, apt will go get it for you on a Debian or Ubuntu machine. And it's just the standard .NET runtime with the host FXR package. And FXR is how you embed .NET inside of a C application and bridge to it. So it's just completely standard .NET. We are on an older version of .NET. We also need to upgrade .NET. That's on our immediate roadmap. We just released version 1 of PL.NET earlier this year. And I think version 1.1, I'm anticipating lots of version upgrades and hopefully improvements on the software environment and the amount of control developers have over the software environment. I also feel good about the decision to ship it without. We wanted to get V1 out. We wanted to get it in people's hands and open the door to people using it and giving us feedback.
Indeed, thank you. That is very helpful.
Okay, good. And then just a quick word about F Sharp story is similar to C Sharp, but it's not the same because Roslyn is specific to C Sharp. F Sharp has something similar called F Sharp compiler services. And it worked for us, but it had some problems. So we built the second mode of just running the F Sharp compiler to directly compile the DLL. And then you can also load F Sharp DLLs, and it works fine because .NET handles that really nicely. And we leverage all that .NET machinery to have F Sharp and C Sharp both work really well. And of course, you can call C Sharp functions from inside of F Sharp and et cetera. Okay, things that we're hoping to do in the future. We want to upgrade .NET and MPG Both of them are older than we'd like, so that's definitely coming. There are a few data types I want to add. Vectors are definitely on the list. We want people to be able to do AI work in MPL.NET. And then one thing I'm really excited about that shouldn't be too hard is getting Entity Framework working. So Entity Framework is the .NET standard object relational mapper, and it gives you a nice object-oriented API, so you're not just having to sling raw SQL. And it also connects to LINQ, so you can do LINQ queries in C Sharp. And it should just work because it's built on MPG and our MPG API is almost perfect. So we're really not anticipating many problems about that. The biggest load there is just the testing. And actually, that might be a good point to mention what we did with MPG testing, which I was really happy about. We took all of the MPG tests and imported all of them into Postgres as stored procedures. And that took a little duct tape and baling wire to do, but we got it working. And we use the MPG tests themselves as our measure of MPG compatibility. We didn't build a separate test suite. We're just using the canonical test suite. And what we see there is a long tail of small incompatibilities. Our compatibility level is really good. The numbers aren't really good because we have a lot of test failures where, for example, we're throwing a different exception at our low-level SPI interface than the exact exception that the MPG code throws at the socket interface. And there's no one dominant case of that. We've already eliminated all the dominant cases. Instead, now we have this long tail of just like tens and hundreds of minor incompatibilities, but they are really minor. And so I think the compatibility situation is good. That's really important to us for reasons that we will get to later. And most importantly, we have a canonical view. We're using the exact same compatibility measure that MPG itself uses to measure compatibility between release versions. And my long-term dream is that we get to full compliance with the MPG regression tests to where we're holding our compatibility standard to the same level that MPG holds themselves on a cross-release basis. And that is the end of my overview of the architecture, the performance, the testing, and the future. Any questions? If that I was going to talk about next, cross PL collaboration potential. And then we have a bunch of questions that were left on LinkedIn that I thought we could go through.
I have some questions, and obviously
Yeah.
everybody else can jump in at any time, but I just wanted to try and paint even a broader picture. Do you have any support for non-atomic functions or procedures? That is, where you can actually have multiple transactions in a same procedure, so that you
Yeah,
can support multi-transactional functionality, essentially.
yeah, our semantics there are just Postgres' semantics. So we expose SPI to the developer, and we expose that through NPGSQL. Within your stored procedure, you can turn around and re-access the database, and you can do that again through the native API in the native way, the same way that you would in client code. And transactions are exposed there. I don't think sub-transactions are currently exposed. I don't know that people use sub-transactions a ton. I think we will eventually support it. We just chose not to at this stage. But yeah, all the database semantics are exposed up to the client code. SPI is there for you, the same as it is in other PLs, and it's exposed through the native API. And when I say through the native API, this gets to the heart of what MPGSQL does for us. PL Java exposes all this too, but PL Java does it through a custom JDBC, which is different. It's an entirely independent code base to the Postgres standard JDBC adapter. It is not compatible. There are lots of differences. The differences are not measured. And this does something to the PL, which I think is really important, which I show in the white paper. Give me a second here to find it. Yeah, look at this line count. PL Java is 55,000 lines of code. And that is what MPGSQL does for us, right? So not only do we have less than 10% of the line count of PL Java, we do a much better job of presenting the database API to the developer in a compatible, standard, usable way. And this is why I speak so highly of MPGSQL and what they've done for us is our having been able to expose the database to developers through that lens is huge for creating that experience where you really should be able to expect that the same code that runs in your client in principle should be able to run unmodified in the database if you run it in PL. And that was my personal long-term dream of what this project could do is tear down the barriers of where the code runs. You should be able to run the code in the place that makes sense. And it should be a low overhead thing for you to migrate the code from running in a client context to running in a database context. And that's the big thing that I really hope we achieve is create that experience for the developers. And that's why I think our use of MPGSQL as our tool for exposing the database and for the type mappings both is really central to what the project is and what we're hoping to achieve. And that is just transparency where it shouldn't really matter whether you're executing your code in the client context or in the database context. You should be free to run the code in the place that makes sense for you and not have all this database machinery be getting in the way of that decision, which is often really important and which a lot of people don't even think about because it's so expensive to move your code from the client context to the database context. And we want to get that overhead as close to zero as we can get it. I would say that's the central defining vision of what we're trying to do with PL.
Thank you, Todd. And I also had another question, and I remember you have some opinions about this, but I'm curious to learn what are your thoughts and I guess implementation details when it comes to this division between trusted and untrusted languages.
Yeah, I think it's an important question, but I think for example, what the Postgres manual says about this is well intentioned, but fairly naive treatment of the security question from an earlier, more innocent era. And when the Postgres secure language system was built in, to my memory, the early 2000s, it might have been 99, or it might have been 1999, but it's somewhere around that era, somewhere around 2000 or so. We knew much less and had much less perspective on what security means than we have today. And from a modern perspective, in my opinion, the entire trusted language framework inside of Postgres is incredibly naive. Excuse me for 1 second. And if you take the letter of the law of what Postgres says a trusted or untrusted language is supposed to be, then I think only PL Tickle even really comes close to what a trusted environment is supposed to be. And even there, I would not trust it at the level that the Postgres doc suggests it should be trusted. And certainly not with the decrepit state of Tickle in general as a platform. It's just not widely used and not receiving a lot of love. So I think it's really easy to stumble into that mistake of taking the Postgres guidance at face value as if these things are secure. I think the security is highly imperfect and it's pretty fundamental. You're just in the address space, and we don't have set UID libraries where you have internal memory protection inside of processes on, I don't think, any operating system in existence. Certainly no operating system that Postgres runs on. I think VMS is the last significant operating system I can think of that even that had anything like the facilities necessary to provide what you would need here, which is memory protection between different parts of the same program in the same memory space. For that reason, I didn't feel very motivated to engage in the theater of pretending that this thing meets a security standard that I think is naive and largely obsolete. The security question is really important. We address it in the white paper, and we've done research in the direction of how much could we lock down .NET to have it present a reasonably secure programming environment for moderately trusted code. I don't know that you would ever be willing to put completely untrusted code in there, but trust is a spectrum, not a binary. And there are things we could do, but they're really expensive and really intrusive. And if you have someone who knows what they're doing, they still largely can find ways around it. I'm probably a little grizzled on the security question, and I think it's really important for us to be honest with our users and not give fake security guarantees that they then naively rely upon and stumble into security problems. So we are very modest about the level of security that we provide. And yet, that having been said, I do think that for many use cases, stored procedures can and often are a more secure option than the status quo, even with those security concerns, because the status quo is just a client with total permission. And it doesn't matter if you have security guarantees inside of the server if the client just has the keys to the kingdom. And if you subvert the client, then you can do anything you want. And I'll make this point in the white paper. So I do think people should be more, I do think stored procedures are actually a positive in the overall security context. I just think that the specific security guarantees that the trusted, untrusted distinction in the Postgres manual, I think the guarantees that they purport to give should be taken with a grain of salt. They're not nothing, but they're not nearly as strong as you might think if you just take the manual at face value.
Thank you.
Did I answer your question?
Thank you. That is very helpful. I guess what will be great here is maybe to take this particular conversation in a broader context of Postgres ecosystem in general and Postgres extensions developer coalition as well, to see where we can formulate what are the real criteria, like in the times we are now.
Yeah, and I should note that everything I just said, none of it is specific to PLs. This is about Postgres extensions in general. Um, Postgres treats PLs in a special way, separate from other extensions, but I think the security question is almost identical for all of them. It's a little more complicated in PLs, but the fundamentals of how secure the extensions are and what we could do to make them more secure is I think a very interesting question, and one that could use some love, because I think it hasn't gotten a lot of attention over the past 20 years. And yet our understanding of the security landscape has grown immensely over the past 20 years. A lot of the things that were only theoretical 20 years ago are very real and actual today. And so we just have a lot more experience to bring to the security analysis. And I think we could potentially do much better. And I have ideas about how we could do better, but I don't know that this is the call for it.
And just for the benefit of the audience here and the listeners, can you think of any examples where the guarantees that Postgres has in its documentation are just not sufficient? What kind of problems have you run into that that made you arrive to the stance that you have today?
Oh, I didn't think this from our experience. I think this from just reading the Postgres manual and looking at the source code of the PLs. What the PLs do is definitely insufficient to provide the level of guarantee that you would infer from the Postgres manual. All right. Um, and it's just not engineered anywhere near the right level that you would need in order to give the kinds of guarantees that the Postgres manual leads users to think that they're getting from the PLs and from the trusted, untrusted division in the PLs. And I could talk to you for an hour about that if you wanted, but
I
would
would
probably be very
absolutely love that. So
okay.
I
But
would love
it might be
yeah,
it might be boring for the people here who are here to talk about
exactly.
PLs. Or yeah,
Exactly. But what I would suggest
maybe
is,
we do that
as an
separately.
action item for us, let's have another call with whoever is interested in this topic as well. And I think we should come up with a better understanding and strategy, maybe even at the end of it, so that there's something actionable, something we can do to improve the whole ecosystem. So let's note
Yeah,
that
no,
down.
and those actions might be improving the security, but they might also be improving how we communicate with users about security expectations. And they might also be just research of what kinds of things could we potentially do that could be shareable across Postgres extensions. And it might also be getting feedback from the Postgres core developers on their opinions on this. I know they have really interesting and deep thinking about these questions. So maybe hearing from them would be helpful as well.
Precisely. Let me shift the topic a little bit. Just before you move on to the collaboration aspect, which is very interesting, I wanted to see what are the practical use cases of of delivering PL.NET that you had. Basically, have you used it in any applications out in the wild? So, do you have any production systems or somebody you know who runs this?
We do have two very interesting applications, neither of which I'm able to speak about publicly. So there's that. And then we have had some reports of people using it in the wild, but nothing very concrete. And I'm not very surprised by that given our maturity level. I think it's still pretty early in the lifetime of the project. So for example, we want to get on the latest .NET, we want to use the latest MPG SQL. We want to give developers more control over the environment their code is running in. We've still got a lot of work to do to mature this thing and get it to the point that you could run big, aggressive apps in it. And then I also think we have some education to do in terms of getting the word out that PL.NET in its hypothetical final form should be a significant improvement, a really significant change in the ability to use stored procedures as a realistic and accessible way to leverage the database and build higher performing applications. And there's a big conceptual block about this, and this is a big part of why we did the project, is stored procedures had their day in the sun in the late 80s, early 90s. And then we all realized that PL/SQL is terrible. And you have all the SDLC problems. You have a terrible language. You've got the division of labor between the DBAs and your application developers. And the enthusiasm died, and the flame left our hearts for the promise of what this architecture can do, which is significant. It's, I think, for most apps, it's a more secure approach. It's a higher performing approach. And it opens up certain possibilities that are very difficult to recreate in a pure client context. And so for people to be using PL.NET, we need to be reawakening their imagination to what is possible with this architecture. And I don't even think we can really do that until we fix these foundational issues with our immaturity in the project, because the promise is not yet fulfilled in terms of us creating those opportunities. I think we're off to a very good start. And for trivial use cases, PL.NET is usable today. But for big, giant, complicated applications, which is where I think we will shine the most, we still have some work to do. And so version 1.1, version 1.2, I'd say that's around the time when these things really start to open. And that is the use case that I think will be most interesting for PL.NET, is big, complicated, aggressive applications where you care about performance, where you care about security. And we need to reawaken developers' imagination that these things are possible in the face of a lot of skepticism because of the historical problems with stored procedures. And that is indeed the core mission of the project. It's not just about C# and F#. It's about reopening this magical door to application developers and putting joy back in their hearts about the idea of having applications with stored procedures. And to do that, we need to make the experience not terrible. And .NET is a really good vehicle for us making a not terrible experience, because .NET brings a lot of really good answers to these things. Way better than PL SQL, vastly better than that. But also, I think, for example, better than Python. The software environment is more rigorous in .NET than it is in Python in terms of what is an assembly, versioning, the runtime, typing, performance. The .NET just murders Python on performance, both single-threaded and goodness knows multi-threaded. It's an ambitious goal, and I think we're off to a very good start. That's where I would frame our progression. I think we released version 1 at the right time, but after a few more versions, I think we'll really be in a place where we can be trying to convince application developers to take it seriously. And we still have some more work to do on that in that direction, and that's fine.
Thank you. And I remember you mentioned that you took some notes from the comments from the announcement of this talk that you wanted to address in the presentation.
did.
Do you want to do this now or after the conversation about collaboration in the sort of PL community?
Either way, but if anyone else has questions they'd like me to do before we do that, now would be the time to speak up. So speak up while I'm looking at my notes. Okay, how about we do cross-PL collaboration? Okay.
Absolutely.
Good. We wrote the first generation of cross-language benchmarks, and that's what we used in the white paper for our benchmarking. We then did an attempt at a second generation where we took the PL.NET test suite and tried to port it to all the other languages as well. And we did that as a research project inside of Brickabode, both for Postgres purposes and also our purposes, because we were using LLM assistants to do it as a research experiment. And that experiment went okay, but great. And the dominant reason is not that the LLMs can't do code generation. It's that the training data for the LLMs on stored procedures in these obscure languages is extremely limited. There just aren't a lot of PLR examples out there, or PL-TICL. And so the LLMs really struggled with the minor mechanics of how to get the stored procedures working. They would give us decent first drafts, but then it was so much work to go back and manually tune them that we might as well just do it by hand, or we ended up doing it by hand. So that's why we didn't release that version. We might release it. We just ran out of time. We hired a grad student to do it, and his time with us ran out. So that's one thing that we did. I do think it would be really good if we had a standard cross-language testing framework such that we have the same names for the different Postgres PL features. If we had the ability to benchmark ourselves against each other in a consistent way, if we had, just the ability, if we had a uniform test suite, we could be collaborating a lot better, because the test suite serves as a lingua franca in terms of how do these different features map between the different PLs. We'd have a lot more visibility into the feature set of these PLs because we'd have a standard feature taxonomy. And there's some documentation of that, but it's really hard to see right now which PL features are supported in which languages. A shared test suite would really help that. And also, I think it's a way that we could show some love to some of these neglected older PLs, which I don't want to die. There's no reason for PL Tickle to die. If someone wants it, we might as well keep it going. So that's one area where I'm still hopeful that we can contribute back to the community and be facilitating cooperation between the PLs. Because the other thing too is there's a lot of duplication of effort between the PLs. And the more we can do to allow us to help each other, we're only nominally competitors. I view DB2 and SQL servers support for C# stored procedures much more as my competition than I do PL Python. Although I think they also should be taking our code and making their products better. It's free software, right? So that's probably the major area where I'm hopeful of more collaboration within the PLs, and then potentially with extensions in general, although probably that one would be pretty local to the PLs. And then for extensions in general, I think if we were having more conversations about the extension API, there are probably some things that we can make better. To give a trivial example, the SRF API is really inefficient. I don't know. There's always this judgment call of how much do you really mind inefficiency inside of Postgres in general, because the overall performance is pretty good. And the API overhead is usually swamped by the IO overhead. So does it matter? And is it worth it? I don't have great perspective on these things. But if there were things that we should be improving, then it would be great if we were figuring that out together, precisely because I don't have great perspective on it. But if someone else were saying this API is really a problem in these cases, I could very easily offer opinions about how to make it better or what we would like a new API to be. So I do think there's scope there for extension authors in general to be having these conversations. And Yuri, that's why I really admire what you're doing with this group. I think it can be very positive. And it's something that our team would be very happy to participate in. And indeed, today we are participating, and hopefully we can continue to participate in the future. But we want the entire ecosystem to succeed and be a helpful influence on other PL and extension authors. And if there's a way that we can do that, we want to do it.
Sounds great.
Yuri, I'm curious your perspective on all that, because I think you are the world leader on that question.
My perspective has been the same for quite a while. I think we really need at least two directions of work, and they're very similar to what you've been saying. And that is one, basically the compliance test, and as in basically which part of the feature set, feature matrix, a particular PL implements. And we can take different dimensions there, such as functional completeness, resource overhead, etc. But also the guidance. So basically, how do you implement a PL that would go much further than Postgres documentation would go in right now? So basically, helping people to implement many more languages, at least experimentally, to create this motion that there's a lot to be done in the community. So here's a very popular opinion as well that
Can I give you a specific supporting example of that? When we were building PL.NET, we probably got 30% of our guidance from the manual and maybe 70% of our guidance from the other PL source code, right?
I have a very similar story. I haven't implemented a lot of languages.
I feel like I know PL Python's internals backwards and fucking forwards at this point.
Yeah, I've read that one a lot as well.
And hats off to them and a note of appreciation. Thank you guys. It's really great.
It does help a lot. But I also think that sometimes just cargo calls in existing implementations is not the best thing because the resources spent on PLs can be limited by the core team and the project keeps moving forward, the overall project of Postgres. And so sometimes it's good to probably revisit certain decisions and see what can be done that is even greater than what, let's say, PL Python has. But as the basic guidance, it's absolutely fantastic. Last year, I was implementing experimental support for Prolog, and I definitely consulted a lot with it. Although Prolog, obviously being a very different language, it doesn't really even have a concept of functions. So I had to reimagine a couple of things.
Yuri, keep talking. I have to step away for around 90 seconds.
Okay. But yeah, returning to the topic of creating support for PL enthusiasts and practitioners to implement, I think it's very important. And that the guidance that I'm proposing that we need to create, I think will be very instrumental in that. I think one of the reasons why people often prefer PLPG SQL is that it integrates directly with SQL, and that is SQL is essentially part of the language. And that,
hey, Yuri, I'm back.
Yeah. I was, by the way, talking about PLPG SQL, and I think it actually touches on some of the questions you were noting before. I was talking about PLPG SQL and why people tend to choose it. And I think one of the reasons, a major reason really, is because it integrates with SQL.
Yeah, I think that's a terrible reason.
That is a reason for sure. And basically, the argument to be made there is obviously that you don't have to deal with strings. That is, it's part of the language. And so your variables integrate directly with SQL. So you can say, select something from something where
I would
use the variables from your language.
I would push back on that. I would push back on that, but I'm going to let you finish first.
Yeah, I'm done there. It's your stage now.
What I would say is PL SQL does a good job of exposing database functionality in the native way. Okay. Native to itself, and it's SQL, and it exposes it as SQL. My negative pushback on that is SQL is a terrible way to do SQL, and it's assembly code for databases. And most applications are much better off using a native API like an ORM, where they're not throwing around SQL strings all the time inside of their application. And so if you postulate an ORM kind of experience where you can fall back to SQL where you need it, but for 95% of your use cases, you're doing something like LINQ or the Django ORM or some kind of reasonable coding experience for the developer, that's a vastly superior experience to me than throwing around raw SQL inside of your stored procedure because it's SQL to SQL, right? It takes the question for granted of what is the right way to be interacting with the database. And I think ORMs with a fallback to SQL are a way better solution than just straight SQL. And if you're a database nerd, you might disagree with me. And I don't begrudge database nerds their handcrafted assembly code if they want it. That's fine. But when I think about trying to build great applications, most application developers, ORMs are a superior choice for 90% of their database interaction. And so for that, I would say, for example, version 1.2 of PL.NET, where we have entity framework enabled, which is very much next on our roadmap, I can go in and I can use LINQ in C#, or I can use Entity Framework, and I can natively express these things in a C#y way and have all the database interaction I want. And my question to you, Yuri, would be, is PL SQL really superior compared to that? I don't think it is.
I mean, it really is a matter of perspective. Some people really prefer writing SQL.
Yeah,
You know,
but
can't
but
fight that.
here's my cheat code in that, right? ORMs don't stop you writing SQL. They save you the necessity of writing SQL in the trivial cases, which are like 90% of the stuff you write.
Yeah,
And that's my
yeah,
argument
don't
for it being
disagree with that.
superior.
Especially if we take the concept of our ORM a little further and also look at tools that allow you to generate code that does SQL. So basically, query builders. So
Sure.
without necessarily mapping relational data to objects, which does seem to receive a lot of
I'm,
pushback
can,
for a
can
lot of
we,
reasons
yeah,
today.
can we, sure. And we can, let's say ORMs, etc. How about that?
Yeah,
Because my point isn't really specific to ORMs. My point is doing it in a native, natural way, which creates a good experience for the developer. And if you choose that to be ORMs or query builders or raw SQL, to me, that's all fine. But we should be empowering the developers on these things and letting them use the things that are natural to their environment. And that's my pushback on PL SQL is great because it's just SQL and you don't have to manipulate SQL. Is you shouldn't be manipulating SQL strings anywhere nowadays, with very few exceptions. It's exceedingly rare nowadays that you actually need to be handcrafting SQL as opposed to using a query builder or an ORM or whatever, just on a lines of code basis.
yeah. We have a raised hand.
Yeah.
Opinion. Personally, I would prefer school mostly in SQL and most higher level languages, higher level language. But I guess it's more of a matter of what the developers want, right? My ideas are not shared. I'm saying for most people, for the vast majority of developers, they really want to do their own like object-oriented work. The people who are into PG SQL, I am, to be honest, are really the minority, right? It's good because you can bring those people, provide something of value to most developers, which is having a code run transaction in a BMS. Now, in the most of the
Yeah, and this goes to the sense of mission of what are we trying to do, right? Are database people just building things for other database people, or are we trying to empower users who are not database people, right? Because I would never stop a developer from using raw SQL if they want to. I would never make that more difficult than it needs to be. And in PL.NET, it's not difficult at all. But if I can open the door to allow developers who shouldn't be focusing on databases, who shouldn't be sitting there crafting a ton of thousands of lines of SQL, if I can empower them to leverage the database and use Postgres, it makes the world a better place than if they're using Mongo.
It's a good point. And I think the other reason why people use PLPG SQL is not because the language is good or bad or anything.
Because, and I'll
it's
put
available.
this on the record. Yeah, and I want to put this on the record because it's not. It's not a good language. It is the worst kind of late 1970s clutched together. No one knows how to build a parser. Language written for the machines, not for the humans. It's terrible.
clean your eyes just right, you can see the relational model. Okay, you can't do hard if you have to get away.
If you squint your eyes at a screen full of PLSQL, then the two images merge and you see a 3D image of the space shuttle.
I'm not kidding. If you can't use that SQL relation, and then you become like a incredibly performant and
Yeah, but I don't think
are not aware of it.
Yeah, but I don't
Like,
think
you-
link. I don't think link, for example, is a terrible answer to that either. Or the Haskell database abstractions, which are actually, I would argue, even more beautiful and more purely functional. But again, it's not about the. To me, it's a lot about the attitude of what are you trying to do. And what I want to do is I want to allow application authors to build great apps leveraging Postgres. And I don't feel any particular motivation to try to strong arm them into a SQL view because I think it's often counterproductive for what they're trying to achieve.
Fair. And speaking of the language, yeah, I think
And also, PLPG-SQL is single-threaded and slow, and making cross-function calls are terrible. And there's no library, and you can't build real applications in it, and it's terrible and all. There's that, and there's that too. Right.
yeah, those are all fair points. And just addressing the syntax thing, I think its syntax was essentially cargo Carlton on Ada. They took the shape of Ada syntax without really taking the values of Ada per se. So they
Yeah, but if you look at other early 70s syntaxes, it's just very much of that era. It's the syntax built for the machines, not the humans.
Part of that, there are the different opinions where that syntax comes from. Again, the Ada part is actually not about machines, but the human comprehension and verbosity, like built-in verbosity. But anyway, it's outside of our scope per se. Bottom line, I do agree a lot with you that the more we can expose this to developers, that is not to database people per se, but actual developers, the majority of them, the better. And how we achieve that's a good question. And there are different opinions.
And I want to be pulling developers into the relational model, not pushing them away from the relational model with high church snobbery.
That's a good one. Yeah, definitely makes sense.
And also, I want to apologize. You and I are on different continents, so with the latency, I'm accidentally speaking over you, but it's not intentional. So sorry about that.
No worries at all.
Shall we, any other questions on that, or shall we look at some of the internet questions? Anyone else in the call want to put their hand up and ask something? Okay, let's go to the internet. I love .NET. I'm using it for version 1. I don't see much point in these language extensions. PLPG-SQL allows me to use SQL directly and seamlessly. Yeah, but it doesn't allow you to take your client code and transparently run it in the server. That's point 1. That's the big thing we're trying to make it possible for you as a .NET developer to do. And I think being able with a compile flag to relocate where your code executes is something that will make the world a better place, and that's what we're trying to make happen. And I don't think that really conflicts with your love of PLPG-SQL, but I do think it opens up exciting new opportunities to leverage the database, leverage the security, leverage the performance, and build really great applications, which today it's massively more expensive to do that with SQL stored procedures that are separately coded than it is to make your code portable between the client and the server. And I've not heard any of these normalcy bias, historically we did X kinds of arguments that have convinced me otherwise. And that's just one man's opinion, but there you go. Let's see. I miss XML query and Postgres. Will this help? I think .NET in general is very exciting in terms of bringing a really powerful library and letting you leverage it. .NET is not alone in that. Python, of course, has a great library. Java does as well, although I don't think I think PL Java would really need to have a lot of improvements to make that practical in a Postgres context. But a big library matters. It matters a lot. And this again gets back to why I find the PL/PG/SQL answer so dissatisfactory. There's no library. I tried to write a trivial benchmark, just counting tokens in the Wikipedia data. The regular expressions in PL/PG/SQL are awful. They're archaic Unix ones and not even modern regexes. It's just a very primitive language. And the syntax is bad and the performance sucks, etc. So I do think things like XML query and the 1,000 other things like them, bringing the entire .NET library into Postgres, I think, is a very powerful thing, and it's something we very much want to do. Let's see, this guy's genius, and I agree with him completely. And then most implementations seem to be flawed in various small ways. Yeah, I think the PLs in general could do better at that. For example, why can't I use SQL Alchemy or the Django ORM from PL Python? Why do I have to use this low-level SPI API? And of course, there are historical reasons why it ended up that way. But is it a good thing for developers? I don't think it is. Python has a deeper problem to solve than we do because there are multiple widely used ORMs for Postgres in Python. So if you were to do this kind of thing in Python, you'd have to do it 3 or 4 times, whereas we only have to do it once. So we are cheating, but cheating is allowed. And that's very much what we intend to do with leveraging MPG-SQL, and why we put so much work into not recreating the MPG-SQL API, but rather reusing MPG-SQL directly so that we have high confidence that the API is exactly the same, leveraging their regression tests and holding ourselves to that standard, where in the long run, we want to have perfect MPG-SQL compatibility as measured by their own tests, precisely so that these small impediments to code mobility can be eliminated, because that's the path to having applications leverage the power of Postgres more. And that's a big part of what we're trying to do. And he loves PL SQL. And Oscar loves JavaScript for stored procedures. Is Oscar on the call? Hi, Oscar. I don't think Oscar actually loves JavaScript, but maybe he does. I haven't talked to him. And those are all of our internet questions. Yuri, did you see any others on the other channels, Twitter or Hub? I don't think I did.
No, I haven't.
Okay. In that case, we have gotten to the end of my prepared remarks. And that is the end of my presentation.
Thank you,
Now-
Todd.
Yeah, sure. Any final questions?
Please raise your hand if you have a question.
And also, I'm curious what people think. Does anyone have an opinion?
I give mine, right? I think it's of the same nature as project. Trying to do meaningfully what the microservice has tried, right? Which is integrating disparate technologies and all things their own. But this provides a much saner and active path. But I think the competition is actually in terms of sample space. So the whole microservice movement.
Yeah, I always shy away from competition as a framework because, for example, if I were building microservices, I would use PL.NET to still stick code to execute in the database where it gave me a performance or security advantage. But then also, what are we trying to do? The more options we open up for developers, the more optimal their architectures can be. And so I don't really need to be negative about other architectures in order to be positive about this one, because to some degree, developers make good choices. The goodness of their choices is greater than 0. And so the more options we have, the more people can be building great applications which approach the limits of what the machines are capable of in terms of achieving their goals. But I'm very much a cooperation over competition guy.
Thank you for this. Looks like we have no other questions. I can see Andre saying that this is interesting to try. So this is good news for PL.NET that people are interested to try it. I'm certainly interested to find time to also try it out, considering the amount of time I spend developing logic inside of the database.
Cool. You can find us on GitHub, and we have a community there, and we reply to queries there, and you can email pl.net@brickabode.com. And a plug, if you have applications you need built, you should hit up Brickabode. We're a wonderful software development shop, and we do good work. So if you like this, feel free to call us up about building your apps.
Fantastic. So I guess that concludes the presentation. It's been a little bit over an hour. So that's great. Thank you everyone for coming.